Time to add live data, so let's start by going to the official documentation to find out how to add the dependency. As we plan to use both live data and view model, let's pick the first one. We will also need this annotation processor. Now we can add these two dependencies to our build Gradle file and sync. Once sync is done, let's open our TaskDAO interface. The loadAllTask method is currently returning a list of task entry objects. Every time that we need to know if there has been a change in the database, we need to call this method to query our DB again. As we have already discussed, it will be much more efficient if we could be notified when there is a change in the database. Thanks to Android architecture components, that is as easy as wrapping our returning object with live data. If we try to build our app, we will get a compile error. The reason for this is that we have changed the returning object type of our loadAllTask method. LoadAllTasks is used in our main activities retrieve task method. So let's also wrap our task variable in a live data object, so it matches the expected return type. We promise that we will be able to simplify all this. Finally, we are ready to go ahead on that. The first simplification comes from the fact that live data will run by default outside of the main thread. Because of that, we can avoid using the executor. Then we can extract all the logic and remove the executor. Notice that we can do this because we are using live data to observe changes in the database. For other operations such as insert, update or delete, we do not need to observe changes in the database. For those operations, we will not use live data, and therefore we will keep on using the executors for insert, update and delete operations. You will also notice that there is a compilation error due to a type mismatch. That's normal because we are in the middle of some changes. We will fix that soon. For now, let's go step by step and focus on completing this refactoring. Our task variable is of type live data, so we can call its observe method. This method requires two parameters, a lifecycle owner and an observer. So, what is a lifecycle owner? We will talk about lifecycle owners in more detail later. For now, let's keep it simple and say that a lifecycle owner is something that has a life cycle. In our case, that will be our activity, so we can use the reserve keyword this. For the second parameter, we can just create a new observer. This is an interface where we need to implement the onChange method. Notice in the autocomplete that this method receives a list of task entry objects, which is the same thing that we are wrapping inside our live data object. This onChange method can access the views, so we can use it for the logic that we currently have on the runOnUIThread method, which we can delete now. To complete our refactoring, let's use the task entries variable to update the adapter. Let's also add a logged message here. To sum up, we are getting the live data object and call its observe method. This happens out of the main thread by default as we are using live data, so we do not need the executor. We have our logic to update the UI in the onChange method of the observer, which runs on the main thread by default. Now, let's scroll up to our delete logic in onSwipe. Every change in our database will trigger the onChange method of the observer. Therefore, we will not need to call the retrieve task method after deleting a task. Also, we can now move the call to retrieve task method from onResume to onCreate. As we mentioned, we were querying the database many times just to check if there was any change. Let's see if we have actually improved that. When we launch our app, we can see that we actively make a call to the database. In this first occurrence, the database has not been actually updated, but the live data object has received the data from the first time, which also triggers the onChange method. Now, if we click on our floating action button and come back to this activity, we can see that we are not actively retrieving the task from the database again. Now, if we swipe to delete one of the tasks, our onChange method will be triggered again as a result of the change in the database. Now our app is much more efficient.